Hello, everybody. Noble Demon Lord here, and welcome to a special episode. I hope that I get to do more of these in the future, but today, rather than a video game or a talk show between Dragon and I, we're actually talking about a very recent event in history, specifically space history. And by recent, I mean going on right now as of the recording of this video, and it'll be yesterday as of the drop of this video. So we're talking about NASA's DART mission. Now, NASA's DART mission launched a year ago, back in November of 2021, and essentially it is to crash a probe into an asteroid on purpose, which is super cool. Now, those of you that know me, you guys know that I absolutely adore space. I love space. Space is my favorite, and I kind of this mission kind of snuck up on me. I knew about it when it launched, but I totally forgot about it until literally today. So now I'm going to talk about it today. And NASA is doing this test in hopes of ensuring that whatever system they're attempting here works, and ensuring that the Earth is not destroyed by a killer asteroid, kind of like the one that knocked out the dinosaurs and made the Gulf of Mexico. That's the hope, anyway. And the DART mission, right? DART stands for Double Asteroid Redirection Test. And as we get into this, I'll cut in some imagery of the DART mission provided by NASA and some other imagery that we'll kind of use. But here, this will also include some of the live streamed footage and imagery, as well as some of the NASA voiceover data and stuff like that. I'll be able to watch it and react to it as we go. But for now, I'll just kind of explain how DART actually works. So DART stands for the Double Asteroid Redirection Test. And why is that? So essentially, the double asteroid Didymos, right? So Didymos is a large asteroid. It's called a double asteroid because there's a smaller one that is orbiting it. So Didymos is the big asteroid, and I'll put an actual comparison of sizes here. And then Dimorphos. Dimorphos is like a moonlet. It's a minor moon. It's quite small. It's only a few hundred meters. Well, actually, not even a few hundred meters. But Didymos is almost as big as the Burj Khalifa, right? We like to compare things. But yeah, it's super cool, and so let's just get right into it. Some of the contributing, I don't want to say companies, 'cause that's not right, agencies. NASA, of course, the Planetary Defense Coordination Office, the European Space Agency, Italian Space Agency, the Japan Aerospace Exploration Agency. There is a ton of people and science behind this. Now, originally, right, the ESA, European Space Agency, and NASA were going to do two different tests on their own. And then by 2015, right, they kind of had this cooperation and collaboration called the Asteroid Impact and Deflection Assessment. And they were essentially, the European Space Agency was going to launch a spacecraft out to Didymos and orbit it for a while, take up some imagery, some mechanics, do some math, get back some data. And then DART was going to go up there, bam, hit Dimorphos, and change their trajectory, and that mission would then hang out, figure out like the asteroid's physical properties, like any of the resulting fallout, as it were, and data changes from before and after. Now, European Space Agency couldn't afford to do that. They decided to launch a system up after DART, and this is called Hera. So Hera has been launched out. Excuse me. It would essentially it's going to observe the asteroid 4 years after the impact, right? So we're going to be tracking it with radar, telescope, and other space-borne instruments to track these two asteroids and see what the reaction would be, but then actually get a physical spacecraft out there in 4 years to observe at close range what that would look like. And it's so crazy that it went from this kind of its own nebulous idea and then in 2015, NASA and ESA got together, and then they broke up in a way, right? So they kind of canceled on one side, but they picked up a secondary type mission, right, to see the after effects. Remarried into the program. And in 2017, NASA approved that proof of concept, and then 2018 approved the project for assembly, and then they launched it in 2021, which is really fast. Launching it in 2021, they took off with a Falcon 9, of course, SpaceX craft. But still, it's pretty freaking crazy. So, it launched, and it didn't launch to much in the way of fanfare. I barely remember the launch myself, which kind of sucks because I do enjoy a good a good NASA launch, just like anybody else. And the rocket itself, sure, Falcon 9s, they happen all the time, right? And everybody right now is waiting with bated breath for Artemis 1 after the numerous scrubs of the launch. And now, with the rollback to the vehicle assembly building with Hurricane Ian, it's kind of rough. October 2nd is the next time frame for Artemis 1, so keep that in mind. I may do a reaction video to that too. I think I would like to. It really depends on what time they launch. But anyway, for now. So the DART itself, right? So the DART spacecraft is an impactor. The whole point is that it's supposed to run into the asteroid, right? It's supposed to run into Dimorphos. That is the point. We're supposed to move it, right? Now, it's not the same as Deep Impact. So Deep Impact hit a comet in 2005 with a lot of energy, about 19 gigajoules or so. But it's not supposed to be that much, right? It's not nearly as large as Temple 1. Temple 1 was the comet that it ran into. Now, the impactor itself doesn't have any science instruments on board, which is crazy, right? Most of the time, spacecraft like this will have science instruments, so they can actually measure, anything really. But in this case, it's a 1,340 pounds, so 610 kilogram impactor, and it only has sensors to figure out where it is in relation to anything else. So the sun sensor, a star tracker, and a large, I say large, a 20 centimeter aperture or 7.9 inch camera. The Draco, the Didymus Reconnaissance and Asteroid Camera for optical navigation, right? Now, it's kind of based on the Lori from New Horizons, right? Essentially, the whole point is that it can look at where it's going, it can transmit those images back to Earth, and help the scientists decide, how it's going to impact. And I mean, it's kind of more or less an automated trajectory. It's far enough out that any sort of commands are not just going to be immediately taken to the craft, but they can at least take a good look. It also uses a next ion thruster, so it's like solar electric propulsion. It's super cool. It's this brand new tech. I do remember that launching, and it's using essentially xenon. It's using xenon to create thrust to throw electrons or ions in this case out away from the spacecraft to make it accelerate. Now, it's essentially the first spacecraft to use a new high gain antenna as well, the spiral radial line slot array. And for those who care, it operates the X band of NASA's Deep Space Network, so 7.2 to 8.4 gigahertz, and it's essentially like a flat antenna. It's like a disc. It's kind of got a spiral, and I'll put up a picture of DART, and then the big kind of white disc hanging there will be the RLSA, the Spiral Radial Line Slot Array. Super, super cool. And now, observation-wise, right? People all over the planet are going to be watching this. Now, obviously, we're going to have Draco's camera images up until impact, but we have a number of Earth-based telescopes or monitoring DART's impact. Hopefully, right? Uh, we'll be able to see kind of a dim, as it kind of goes as Dimorphos goes behind Didymos, and then brighten up as it comes back around, and then hopefully it should get a little bit brighter at impact. But we'll see what happens. We'll see what happens there. Now, there's also another I say asteroid. That's not correct. There's another spacecraft, the Lycia Cube, the light Italian CubeSat for imaging of asteroids, piggybacked with DART. It's separated on September 11th, 15 days ago, 16 days ago for when this video comes out. And it's going to attempt to get images of the impact and ejecta. Now, I might do another video in the future where I include that, or I might just mention it in a sidebar. But Lycia Cube has 2 optical cameras dubbed Luke and Leia, because, I mean, come on, who doesn't like Star Wars, right? But yes, so Hera ESA's aircraft will be launched in 2024 and arrive in 2027. So we've got a number of items, right? It was supposed to be 4 years. Now it's 5 years as far as actual items go. It should be carrying 2 CubeSats, Mulaney and Juventus. Now, or Juventus, whatever. Not 100% sure what those are doing yet, but the whole point of this is that this is a monumental mission as we head out into space, right? The Earth and humanity as a whole needs to get into space, right? Earth is our cradle. We're just infants trying to get out of the cradle, right? We are taking our toys and launching them across the room. And we're just watching, we're observing, we're learning. And it's so cool that we're able to do this, right? If all of the funding that like the militaries of the world get could be directed at space exploration and science, humanity would be better as a whole. All of us would be far better off, and we know so many more things, so many more anything really about astrophysics, about space, about planetary sciences, about the environment, about weather. There's so many things like medicine, even like growing things in 0G, and hell, we could probably be at Mars by now. And obviously, the Artemis mission is working toward that. But I have very strong feelings uh, about space and humanity and what we should be doing. But that's neither here nor there, I suppose. But yeah. So we'll come back to it as we do the live stream. So hang tight.
5 minutes out, which we're coming up on now. The team will be hands off 2.5 minutes from impact. SmartNav, which has been guiding the spacecraft autonomously for 4 hours, will also step away, stop any maneuvers. DART will simply be coasting to its fate. This is blockbuster stuff, Lori.
Oh, yeah. Oh, yeah.
God, this is so cool. Like,
we are there.
Just seeing the 2 asteroids there, like,
very soon
we're so close.
Open up these airways.
I've been watching this for the last, like, hours.
Center. We'll stay plugged
and there's
in
just a little
of
dot, and now it's like...
Remember, at this point, 5 minutes out, no more commands to SmartNav will be possible.
Oh my God, it's so cool.
The team is watching it just
obviously,
like
there's
the
countdown up there. Oh my God, this is awesome. So yeah, obviously credit to NASA for this, and for the commentary, right? So this is awesome. This is amazing. I am super stoked about this. God, this is so cool.
All right, we've reached 5 minutes from impact. The final command opportunity to SmartNav has passed, and the team is simply watching that data stream in just like we are. Also remember, there is a 38-second lag.
38-second delay.
To Earth, and also an
additional just how far away.
Seconds for image processing. It's important to note that.
And it's 1 frame per second is what we're getting here. Whew. Oh, man.
You should be hearing the chatter in the Mission Operations Center momentarily.
I'm going to leave this all in. If you guys
this is DART MSC on DT
missed the actual live stream.
5 minutes till impact. We are at 1,100 miles away.
1,100 miles. Holy crap. So, if you guys really want to see it, skip forward 4 or 5 minutes.
Also, our window for sending any commands to the spacecraft is done.
But
Contingency's done.
here we go. So, if you guys want to sit here and watch through it, and watch all the stream out of NASA,
This is a great vibe in
It's a
that
great time
to do
it.
Mission Center right now, Lori.
holy crap,
It really is. They are so excited.
this is so cool.
And
This is investigation
you know,
one on DT
I'm
Mach.
honing in, looking at these images as we get closer and closer, and you look at Didymos, and just you're starting to see this physical body appear there. It's incredible, just incredible.
That sounds great.
I'm still having a hard time believing this is real imagery coming in near real time.
This is so cool.
Yeah, but you've been watching it over the last, 30, 45 minutes.
1,100 miles.
Collection of individual
And we can
pixels,
see that.
and now you can actually see
insane.
the shape and the shading and texture of Didymos.
So cool.
And we're going to see that same thing with Dimorphos as we get closer and closer. This is so
That's
cool.
so cool. Oh my god. Yeah, I'm
Never
gonna.
before seen
maneuvering.
images of Dimorphos will come into stark relief a few
Absolutely.
seconds before impact.
I mean, I don't know how
Amazing.
good those those images are gonna be, but 1 frame per second, like it. I'm not sure if this is high res or not, but like,
the team is standing
we're
just
1,100 miles out.
recognizing
Like,
this
it's gotta
moment
be something.
years in the making.
oh my gosh.
It is really nice to see them relax a little bit, get off from those computers that they've been glued to, and just appreciate this moment that's coming.
Yeah, and
Like-
they've earned this.
They
it's
can't
great to see
do
them there.
anything about it, so they have to step back.
This is so cool.
Lori,
I'd be
this
so
is
nervous.
Another major milestone.
Oh my gosh.
We are now 2 minutes and a half from impact, and SmartNav has stopped maneuvering the spacecraft.
Oh boy.
DART is now coasting toward Dimorphos, and we hope into the history books.
Distance.
It would really suck if it
Absolutely.
missed.
This will be, I'm sure you've heard it many times
Oh,
tonight,
God.
humanity's first ever attempt
Wow.
at trying to move another
You can actually really
celestial
see
body. And also
down
our
here.
first attempt ever to
Just
execute
Didymos.
a mission in sole purpose of planetary defense.
That's so cool.
What an exciting time. Yeah, and I'm starting to see Dimorphos start to come into view there. You can see it starting to take shape. I'm starting to see individual boulders on Didymos. Unbelievable.
This is so cool.
Unbelievable clarity of images there.
Wow, I love this.
Distance is going to
Holy
be about
shit.
17 meters.
This is killing me. Wow, this is so cool. 17 meters, holy crap.
All eyes on this event.
Wow.
Space telescopes, ground telescopes
Holy
from
crap.
every continent on Earth.
Wow.
Yeah.
Yeah.
I don't even know what to do. I don't even know what to say.
All right.
Like, I'm just watching. You guys are going to be here with me
Does
watching
not look
this,
like one single
reacting
Oh, boy, we're
live.
getting close.
Whew.
14,000 miles per hour.
14,000 miles an hour.
14,000 miles per
Holy
hour.
crap.
And remember,
Wow.
45 minutes ago, 55 minutes ago, we couldn't even resolve this
is
object
insane.
in space.
This is
and
so
now
cool.
we are, you can
Uh-oh.
see us
Here we go.
zeroing in right on target.
Oh
And
my
we're now
god.
dropping
Stay on
the
target.
clock, and we'll go by
Stay on
loss
target.
of signal to confirm impact.
Loss of
Right.
signal. Holy crap.
Yes. Imagine we'll get that loss of signal, and then
Wow.
we'll hear from Lena Adams again, and letting us know that
I
we've
feel like
been
we'll know. I feel
successful.
like that'll be a crystal clear signal.
I think
And already
so. I think we're
Didymos
starting
is
to
out of
see
view.
More,
You can see some boulders on
more
Dimorphos.
resolution. In fact, look at that. Didymos has even gone out of the view. We're
Wow.
now just seeing Dimorphos.
This is so cool.
This is remarkable stuff.
I'm like blown away. This is amazing.
Oh my goodness.
I'm
Look
like
at
gonna
that.
cry. This is awesome.
Looks like control
Humanity's
system's
amazing.
settling down. Angular rates look really good.
Oh my
I think we're
gosh.
going to get the investigation team some good pictures.
Oh my gosh. Come on.
Wow.
Oh, it's so close. We're moving so fast.
No, come on. We can do better than that.
Starting to see those individual boulders
Oh, the
there.
nerves.
You can see shadows.
We're this
on
close.
various
30
rocks on the
seconds till
surface.
We're like
impact.
trying to hit a grain of rice with a rifle from like
Oh my
20 miles
goodness.
away.
Look at that.
Moment of truth.
Unbelievable.
Yeah.
Holy crap. Wow, look at it. That's so
Looks
cool.
like we're headed
Look at
straight
that.
in.
Oh my god, that's awesome. Holy crap. Oh my god, that's awesome. So it's 38 seconds. It's probably already hit, right?
Oh, wow.
Oh my god. Oh my god.
Oh my goodness.
Yeah.
Oh my god. Look at this.
Wow.
Oh my god, that's so cool.
3,
Oh my god, I think we got it.
1.
Wow, look at that.
Awaiting
That's-
visual confirmation.
Wow. Oh my god, look at that.
All right.
Wow. That's so cool. Look at that. Look at those high-res images.
And we have impact.
Oh, my God. Wow.
Humanity in the name of planetary defense.
Congratulations, NASA. Congratulations, ESA, NASA,
Oh,
the Japanese Space
fantastic.
Agency. Wow. Holy crap. Absolutely amazing.
What a moment.
So, I did my entire outro, and I wasn't recording. So, there's that. I'm going to have to recreate all of those emotions. That's cool. Holy crap. Well, look, I'm going to put the last 30, 40 seconds of just the camera, of just the Draco coming into Dimorphos without the NASA speaking, without me speaking, but I just wanted to take a second and just, wow. Congratulations to NASA, to the ESA, to the Japanese Space Agency, to everybody involved. That was a beautiful display of engineering, of space flight, of human ingenuity. It's just amazing. I'm tearing up just thinking about it, and obviously you can see I'm a little bit like red just from the emotions because it's so cool. It's so amazing. I'm absolutely in love with space and the lengths people will go to learn, and I can't wait to learn in 4 or 5 years when Hera gets up there, what data we can collect and maybe how big of a crater we left on there and all that really cool stuff. And I'm super excited for the future of space flight and humanity. And I just want to thank you guys for coming on this journey with me to watch this awesome NASA mission to save the Earth, a proof of concept to change the trajectory of an asteroid. So awesome. I really hope that we learn more over the coming days, weeks, and years. Please, I really do enjoy sharing these with you folks. This is the first time I've done a video like this, but this is, frankly, amazing. Super, super cool. Thank you guys so much for watching. If you do enjoy these videos, leave a like, comment, spread the video around. I absolutely will do these just for fun, but I hope that maybe my little snippets can educate people, and I can share my wonder with the world of space. So, again, thank you guys so much for watching, and yeah, I'll see you again. See you guys next time.